Hello, and thank you for listening to AI Success Factors podcast. We help enterprise adopt artificial intelligence. This is Samuel Matthew, your host. In simple terms, AI adoption is a three-step process: identifying the right AI opportunity, tying it back to a business value, and aligning it to a business goal. If you're a leader, needs help demonstrating ROI on your existing AI initiatives, or want to get a buy-in for a new AI initiative, you are in the right place. Our mission is to empower enterprise leaders to navigate, transform, and lead by applying AI into their business. In this show, we interview analytical and business leaders who successfully implemented AI into their business. In the conversations we feature, you will learn how these companies reach strategic business goals. It's a pleasure and privilege for our listeners to develop a point of view from the insights shared in this podcast. Today on AI Success Factors, we're excited to welcome Raj Prabhakar. His impressive career includes developing over 30 robots, including work on Carnegie Mellon's Moon Rover project. With a master's in robotics from Carnegie Mellon, Raj combines technical expertise with a visionary approach to AI. Raj is the Director of AI and Data Science at ServiceLink, a subsidiary of Fidelity National Financial. In this role, he leads transformative AI and automation initiatives. With a strong background in data science, robotics, and IoT, Raj provides a unique look into the future of AI and robotics, highlighting both the challenges and opportunities ahead. As enterprises explore new horizons with AI and robotics, today's episode of AI Success Factors brings valuable insights for CXOs and enterprise leaders. We'll take an in-depth look at the latest advancement and strategic applications of these technologies. In this conversation, we examine how AI is transforming industries, from robotics innovation to practical use of edge computing and IoT. We cover it all. Our guest Raj Prabhakar shares his expertise on how these technologies boost operational efficiency. He explains how AI drives automation and enables smarter decision-making. Together, we will explore the challenges and opportunities that lie ahead. Raj provides practical perspectives for leaders aiming to leverage AI and robotics to stay competitive in an evolving digital landscape. Here is our conversation. Hey Raj, welcome to AI Success Factors.
Hey Samuel, thank you. I'm happy to be here.
Absolutely. It's a privilege to have you on the show. At Carnegie Mellon, you have been involved in creating more than 30 robots, including working on the famous Moon Rover space project. Hey Raj, I got to tell you this. You had some wonderful opportunities throughout your career. Raj, when we look at the evolution of robotics, we have seen the birth of modern robotics in mid-1900s. Today, robotic systems are far more powerful and capable than their predecessors. They now integrate IoT, edge computing, and AI with applications across various industries. Our listeners would love to hear your thoughts on how these advancements in AI are shaping the future of robotics. Let's dive right in. How do you see the intersection of robotics and AI evolving today?
Wow, I think we are in very exciting times when there's so much progress that's being made in AI. And robotics is basically three things combined. You have something to sense, then there is some processing unit, and there's an action, usually an actuator, right? In the processing, what makes robots intelligent is the code or the algorithms, right? And there is so much development in the recent times with the advanced GenAI, LLMs, all these things that are going to change how the robotics is going to look in the future. In the past, we had very simple computing platforms. From there, we moved into microcontrollers. Like a decade ago, it was all about single board computers. The computers were finally small enough to put on a smaller robot and do it in the edge. But it was still too intensive for any kind of advanced computer vision processing or voice understanding and things like that. All you could do was more simpler tasks, right? LiDARs, there was computer vision, but it usually had its own computer and things like that. Now we are entering an era where everything is accelerated using GPUs. A lot of NVIDIA cards that are designed specifically for robotics that sit on the robot, low power consumption, can run AI on it, like object detection, depth from single camera. These kinds of advancements have come up. The next era is going to be having a unified model, more like GPT-4o, any multimodal models, right? Something like that. Still GPT-4o or Claude or other models are still too large to sit on an edge device today. Most of it is still processed in the cloud. But there is this race that's going on where these LLMs are starting to become smaller and more powerful so that they can sit on an edge device. And the edge devices are also scaling up on the hardware side with its capabilities to process and host larger models. So we are getting close to robots that are very generic, that can perform many tasks. Robotics has always been very specialized tasks so far. So that's the shift that we are going to see going forward.
Interesting. As you talk about the edge computing, I just wanted to understand how IoT and edge computing enable more efficient, responsive robotic systems. And before you answer that, I want to take a minute because our audience is from different industries, especially folks from manufacturing, logistics, understand these technical terms. For folks from other industries, I just wanted to just brief it what IoT is, what edge computing is, before we get into so they comprehend it well, because these are not the normal terms they talk in their day-to-day business. So IoT in the normal terms, IoT is think IoT is something like an ordinary objects, like a smartwatch or car or fridge, can connect to the internet and share useful data. For example, our smartwatch tracks our steps and send it back to an app in the iPhone. Now imagine this idea expanded to the business context. Imagine an IoT device that sits in a factory that captures the temperature on the furnace, or in an agriculture setting, in the farm conditions, it captures and sends it. So it's about collecting the data on the physical world and using it for a better decision making. That's what IoT is, just for the audience. And the edge computing is similar. Edge computing is all about processing the data closer to where it is created. The closest I can talk about this Alexa that all of us might be using it. Instead of sending our question to a cloud server far away and waiting for an answer, edge computing allows Alexa to respond instantly. The same idea with self-driving cars. It needs to process the data real time, like stopping for a pedestrian, sending the data to the cloud and waiting for a response is not fast enough. Definitely, I don't want to be in the front of that car. Edge computing makes it possible for those devices to think right where they are, ensuring quick and reliable decisions. That's what these two technical terms mean. So when Raj explained how this IoT and edge computing make it more powerful, these robots more powerful, then you get more context. You can just give them a brief.
Sure. Yeah. IoT is kind of important because then you're speaking a different language today, right? We all speak in English, a lot of us. There are many other languages in the world, but let's say a lot of devices in English-speaking countries are English. That's why NLP became very important. Now, there could be a time when every device has IoT on it. I have so many devices at home that are all connected to the internet. Internet of Things, right? IoT stands for Internet of Things. Right. So I'm working on a smart home project at home. I like automation in general, personal or professional life. I've been doing this for a long time. So all these devices now can talk to each other. For example, I don't want the robot vacuum at home to start when I'm sitting and doing a podcast like this, or when I'm sleeping, which could wake me up. So I wanted to start only when me and my wife are outside the home when we leave. And sometimes we press the button, sometimes we don't, and it's not such schedule. So IoT enables me to make this happen using various things, right? My phone has sensors and it knows I've left the house. Then how does that communicate to the robot vacuum? A robot vacuum also connects to the internet, and there are protocols that can talk to each other. Now I can set it up in such a way that if I've left the house and I'm out for X amount of time, automatically the robot vacuum starts and starts cleaning the area without disturbing us. This is one simple example. Right. Similarly, in the industrial world or agriculture or any industry for that matter, instead of humans being the touch points to do certain things, the machines and related things can start talking to each other. That's what the IoT enables. So instead of robot having to develop the vision to read some metric on the screen or monitor, which in itself is a challenge. I did a lot of work in machine vision in the past in the industrial setup. That in itself is a big challenge. And we don't want to be throwing challenges where it's not required. So having a simple IoT and a protocol to communicate with each other, I think the protocols that we are standardizing is matter over threads and things like that. Finally, there's some consensus on the IoT devices that's coming up. Before it was Zigbee, it was Bluetooth-enabled devices, low energy Bluetooth. We had ESP home, various things, right? So finally, the industry seems to be standardizing on matter over threads, which is a pretty cool thing, and excited. I'm still waiting for a lot of these devices to come up and start leveraging it. So that's kind of how I'm looking at the IoT. IoT becomes a platform, a language for every device on the planet to start communicating with each other.
Right. So if you look in the applications of it, these technology applications, mostly adopted by manufacturing and logistics is where the robotics applications are mostly. Even healthcare started using it though. So I just wanted to find out your take on how these AI-powered systems transforming the production line in a manufacturing setting.
Sure. The AI-powered systems can definitely do a lot of things on the edge. Before we had to hard code everything, about 15 years ago when I was working in this industry, where I used to work with cameras and production lines, manufacturing lines, it was very traditional computer vision. It was still smart. We could do OCR on it. We could do measurements with it. Specialized lighting was required. It was called machine vision. Now, with the advent of AI and a lot of these large language models, generative models, even deep learning came and changed that to make it more like it's going to learn on the job. You just need a few samples for it to figure out. Before, it was a lot of things. Lighting played a very important role. Lenses played a very important role. Very structured. You had to make it very structured environment. Otherwise, there wasn't enough compute to make these measurements. This is about 10, 15 years ago. Today, there are smarter systems that can work in various lighting conditions. I remember sitting in, back then I was working in India, sitting in a plastic manufacturing plant in Gujarat in 40 degrees, 45 degrees Celsius. It was really hot. Sitting there all day, collecting samples and adjusting for the lighting variation that happens throughout the day. We don't have to do that anymore. It has become so smart that it can understand what is important, what is not, and be able to adapt to changes and pay attention to the right things. And deep learning enable all this to happen, like CNNs were one of the first things that could enable something like this to happen. Today, zero-shot learning is also possible. Of course, in industry, you probably don't need to use zero-shot learning, which is like asking an LLM, multimodal LLM, to say, do you see 5 objects here or 3 objects here? Do you think this quality is good or bad? Do you see a resistor here or a capacitor here? Is it missing? Is it in the wrong direction? You could do zero-shot too, but it's not required. And these models are very large at this point. But you can do a few shot learning instead of having now thousands or 10,000 samples and going from hand tuning to large number of samples. Today, we can do it with fewer samples. So what does this enable us? We have smarter systems that can be deployed in the production lines that employees of that company can now adjust or change as the product changes. This gives you more flexibility. Otherwise, every time the expert had to come and work to change for a couple of days to a new product. And again, when the product changes, again, it changes, right? So we can build more generic systems, something that can be off the shelf, that can be deployed and maintained by the engineers who work in the same company, rather than having experts come and do it.
Exactly. The ability to the production line as the technology changes, especially now with modular robots, sounds like a game changer, and especially with supply chain becoming more volatile now. If you look in 4 years ago, the COVID complete disruption in the supply chain. Now, because of the geopolitical events happening in the Middle East, there are a lot of supply chain issues. So obviously, these systems really help in that kind of situations. So talking about that, when did you see the evolution of cobots in the production setting in your career?
Cobots is definitely new, right? Only these companies that had a lot of money and a lot of repetitive tasks were using large industrial robots, and that has been traditionally, right, from last 30, 40 years. It has been all these large robots, and only large manufacturers could afford it. These days, cobots are so cheap that anything that requires a lot of repetition, I think the traditional robots is good. Because it's specifically built for that. It's a volume game, right? So if your product doesn't change that much, traditional robots are still great. If things are changing, cobots are great, and cobots are meant to handle less weight and be a little less precise compared to the traditional robots. The concept of you being able to teach it, but it didn't take off as expected. Maybe it was ahead of its time. Maybe it couldn't handle enough weights for the industrial applications, etc. But cobots today are used extensively because of the price point, because of their flexibility, and they're easy to deploy.
Is it just in the manufacturing and logistic industries, or is it moving to other industries as well?
I would say every industry can make use of this. The way I'm looking at it with the advancements in AI, a lot of complex tasks are now being able, anything that's specialized and complex is something that we can replace with robots and AI.
Perfect. Yeah, I was watching a kind of video yesterday night. I was looking some information. I was seeing cobots working along with the human as they are changing their pace, seeing the obstacle, changing their route and everything. It's so fascinating, the kind of ability that has come up with. So we just talked about the manufacturing. Also, we have audience from other industries as well. So just have one question on that space as well. I just want to ask you, what are the bigger opportunities in healthcare and logistics that you see in robotic? Because there's a lot of talks about, how robots are assisting medical procedures and such. So what is your check on that?
Absolutely. I had some friends in healthcare. I talked to them, and they're using cobots a lot. Of course, we all know a very popular robot like Da Vinci that existed for 20 plus years now. Very precision surgery. Thing that's changing the healthcare is that these robots now can be used for small adjustments and movements, and also be able to do a lot of non-invasive procedures. Meaning someone had to cut open part of your body to get inside and operate, do a biopsy or do a procedure. Today, these robots can be sent through your mouth and can go in and go to the right place and do some procedures. What I've heard is that they're trying to get this to become autonomous, but the industry regulations are not letting that happen. And there's a lot of risk that's involved, and it's assisting today. All the doctors, medical professionals, it's assisting. The cobots do assist these people to perform the procedures, but not directly do the procedures on human yet. But it's certainly going to be, a matter of time that all these will become autonomous, because we've started seeing that AI is capable of doing it better than humans. And usually these regulations will slow things down in general, but it's only a matter of time. A couple of years down, I think we are moving in a direction where a lot of these procedures could be done using autonomous systems.
Yes, the difference in the healthcare setting is the stakes are high because it's involved the privacy and other aspects of it. So that's the reason why this is going a little slow pace compared to other industries kind of adapting very quickly. So talking about these challenges, bringing these systems into your business, what are the biggest challenges you have faced when combining AI with robotics? I just want you to touch up both technically and operationally, if you could give some light on that.
Sure. In my previous job, I was automating floor cleaning robots. These were bigger robots, meaning these robots are big enough for it to hurt a kid. If it runs into a kid, it could fracture them or hurt them really bad. And the goal of this robot was to clean large spaces like schools and airports, uh, grocery stores, and things like that. So they automatically turn on, go clean the space, and go back and charge. That was its role.
Right.
And I firsthand got involved in a lot of certifications and testing, and it was not easy to convince the authorities that it is safe. So one of the shortcuts that we took at that point was to use a safety rated device as the first level of defense. Like we had a LiDAR that was safety rated. That kind of gave us approvals to move forward and launch this product. And the other option that we were using was stereo cameras, and it would take time to stereo cameras and other sensors, infrared, active infrared sensors, and we also had ultrasonic sensors. So the challenge always was that whoever is making the laws, some of them didn't have this experience or didn't have the knowledge or understanding. And newer people had to get into the boards to start making these changes and come up with these regulations so that some company doesn't immaturely get into production system or start manufacturing systems that are not safe enough for humans or for people in general. So there is that push and pull. No regulations will give you the freedom to grow fast and implement and test. At the same time, regulations will help it be safe for everyone. So there is that requirement. I understand why there's regulations that are required, but at the same time, we need to move fast and move forward really fast. With Gen AI adoption, you're also in the same field. You kind of understand how fast the field is moving, and a lot of these regulations are yet to catch up, especially in like financial services. There are a lot of skeptical people. You need to prove a lot. You need to make sure these algorithms are doing the way it's doing. And a lot of them, it's also about educating them and getting them to approve these things.
That's right. So I think it will be a little more time for people to adapt and accept autonomous systems on the streets and their daily lives. So that is what it is holding up.
Absolutely, yeah. These autonomous systems are starting to seep into a lot of our systems. We have robotic systems. They're not harmful. If it goes and hits something, it'll still be fine. So we start with that. We're looking at self-driving cars coming in the future, very near future. It's already here. Soon we'll start seeing this getting into financial services. We'll start seeing this getting into healthcare at some point. But all these things are lining up in that direction to start trusting the autonomous systems and have the checks and balances to make sure it doesn't cause harm.
All right. Just like electricity, olden times, it can harm, but how we figure it out, how to use it effectively, the same parallels here too.
Absolutely. That's a very important question when we're building any AI systems, because it's like you went to school, we studied, and we graduated. After that, we never learned anything. How effective can we operate in the environment? We can't, right? We all know that anyone who's doing good at the work needs to be up to date with what's happening around, what's happening in their field. But the world is changing, the rules are changing, regulations are changing, people are changing, the behaviors of people are changing. Like, for example, if we take any data during COVID and train on it, and now if you try to run that model, you'll not see good performance because it's not the same behavior. Or if we had the model from prior to COVID and we were trying to do any forecasting or use the model during COVID when behaviors were different, you wouldn't see the same kind of performance. So that kind of is the model drift, right? So it's context dependent. Not all systems will have drift. Like in manufacturing, if the product didn't change, if nothing else changed, then you probably don't see any drift. You don't need to retrain it. But if the product is evolving, small minor changes happening, or if the machine is degrading over time, its performance, the speed at which it's operating, various things, right? If any of these parameters are degrading, it's important to monitor for them and correct for them. How can this happen, right? So first thing is, we're all excited to build AI systems and deploy. Seldom do we give enough thought upfront to put monitoring in place. because it's we did all this test. We're like, yeah, we've thrown out the system. Let's put it into production and start using it. But it's very important to put monitoring in place to see how it's performing. What does monitoring mean, right? So not everything will have the ground truth data, which is to say, I'm expecting this and this happened. Sometimes the system is set up in such a way that you have feedback. What if the system is failing and you don't catch it because there's no supervision on it? Sometimes it has to be manual effort where humans are looking at the output of the AI and saying, hey, you're doing good. Hey, you did something wrong. So if you don't know if it's doing right or wrong, we won't catch it. And if you don't catch it, we don't retrain the model and the AI continues to make the mistake. So there's always a very important factor, which is human feedback. So a lot of systems will require human feedback unless the feedback is somehow gotten into the system. Sometimes using IoT, sometimes if you're like doing stock market predictions, then the stock market outcome the next day itself is your feedback, whether the model did good or not. In certain cases, you might need to ask humans to do it. And that feedback is very important. You need to have infrastructure in place to process the feedback, filter the feedback, and train the model. There are also models that are self-learning over time and get better and better every few days. Reinforcement learning with human feedback is very popular in today's Gen AI terms. Everyone using ChatGPT is part of that experiment, I would say, right? Or any of these large language models, there is always feedback that's coming from users who are using it. So that's how the systems evolve and improve, and you don't see much of drift at that point. So monitoring is very important. Having right protocols and processes in place for feedback is important. And then how do you train and improve the model to prevent any of these drifts is important. Otherwise, the worst thing that could happen is we are not monitoring and the AI is not doing what it's supposed to do a year from now.
Right. Yeah, this feedback loops play a big role in terms of maintaining the accuracy of those output of these machines. I think over a period of time, so this automated model training will become the norm across the industries, I believe so. And before we get into the futuristic view of the robotic space, I just wanted to ask you one more question touch up before we go in there, because we briefly talked about this before, about the privacy of AI-enabled systems. So what are the measures company takes to safeguard data privacy in AI-enabled systems, especially when robots collect personal information?
Right. I think this is one of the very important things that regulators pay attention to. We need regulations, otherwise it's going to be very difficult. Like when I go to grocery store, they ask for my date of birth. I'm like, why do you need it? I'm not going to give it to you. Right? So don't collect data that you don't need. You want the age? Fine. Have a binary Boolean flag saying, am I above 21 or not? That should be enough. We don't need to collect any data that's not required. With robotics, we like to collect all the data we can collect from the surroundings so that we can train the system better and make it more robust. But that comes with a lot of risk too. And this is where I think the edge computing comes into play. Like I have a robotic vacuum that I had to upgrade because the old one was just LiDAR based. And I was feeling fine with the privacy part because there's no cameras on it. And I'm okay with whatever LiDAR information is collected. I was okay with it uploading to the cloud for any processing, creating maps, etc. But now the new one that I got has a camera on it. Like they say as a feature, you can open the app and drive the robot to wherever you want and monitor whatever you want, which is scary. I like to see a lot of these AI move into the edge for this reason, so that your data is not sitting in someone's cloud. And if that cloud is infrastructure is compromised, all the data is gone. And we don't want that to happen. So a lot of edge computing comes into picture when we talk about privacy now. So every company has to be cognizant about this factor and not collect any data that is not required for their work, to have controls to disable any of this data going into a cloud without permission, and make people aware.
Because this has to strike a balance as we go forward. That's what I feel like, that regulators and the creators need to work together, striking the right balance for public to democratize and use
Oh,
this.
that's perfect. I mean, you talked about democratization. I think that's the one that's going to change the game, right? Otherwise, there'll be so much monopoly, so much dangers of all the AI kind of comes into picture. I'm really glad that there are so many companies that are willing to share their models publicly, which democratizes the AI. Because if I were to train a model like Llama 3, it would almost be impossible, because I need the compute and the time and the money and the resources for an individual, or even for a smaller company. It's almost impossible to train a foundational model from scratch.
Exactly. The computing cost is so high for those models. Yes. Just at this time, we'll talk about let's talk a little bit about the future of robotics. And there's a lot of conversation around how close are we in general purpose robots. Do you think we're close enough to achieve general purpose robots, or will the specialized robots continue to dominate in the near term?
In the near term, specialized robots will continue to dominate. When I say general purpose robots, I'm thinking of these robots to be more like humans, like humanoids, right? These robots can then drive, they can do everything that a human is doing. And the whole world in general is built for humans. So a humanoid would be like a perfect replacement there to automate everything. I see a lot of devices coming up today. And I see that we have AI evolved to a level where it's easy to process on board. It is smart enough to understand its surroundings. So I think they're within 5 years from now that these general purpose robots will be working along with us at the rate at which all this is progressing. I see about 5 years. It might not be affordable for everyone to get one, but eventually 10, 15 years, we'll probably see a robot in everyone's home, doing all the chores, taking care of all the things that they don't want to, that they don't enjoy, right? Giving care to elderly and things like that. When it comes to industrial robots, these kind of robots will not be very efficient. So in industrial setting, I see cobots and specialized robots continuing to be used.
Right. Because those tasks are particularly defined, so it can be specialized robots there to work better for them. Exactly. Yeah, this is a very promising future. In 10, 15 years, we see robots in all of our homes doing multiple tasks. Yeah, we're at the top of the hour. Raj, this has been a fabulous conversation. It's clear that the future isn't just about building smarter machines, but also crafting meaningful human collaborations that drive innovation and efficiency across industries. Before we close, do you have any final thoughts or advice for our listeners, especially CXOs and other decision makers in the enterprises?
Sure, yeah. There's a lot of advancements that are pending to happen in physical world. There's a lot of advancements that's happened in AI in the software world, right? Now that's going to be translated into physical world with robots, cobots, self-driving cars, and a lot of smart systems in general. There is that delay between software and physical. In software, AI has progressed a lot. In hardware, it's picking up with all the simulations. It's inherently slow because of manufacturing. You need to build all these physical parts. But that's the next big wave in artificial intelligence, in robotics. And so if you're not thinking about using robots for automation, this is the right time to think about it and start planning before you're left behind. There is no competition for robots or AI today. If a company is using AI or robotics, they're far ahead than their competition, and the competition would not be able to catch up if they don't start planning today for adapting AI, Gen AI, or robotics in the near future.
Awesome. Raj, thank you so much for sharing your journey and insights with us today. And thank you to our listeners for tuning in. If you like today's podcast, please be sure to leave a 5-star review. Your feedback is important. We always look for comments and recommendations to improve. This show is available on Apple Podcast, Google, and SoundCloud. Please do subscribe. Plus, you can find us on LinkedIn, Twitter, Facebook, and on YouTube. You can find the links to these pages in the show notes or by visiting us at aisuccessfactors.com. We publish episodes bi-weekly on Wednesdays. Please be sure to tune in for the next episode. Thank you and see you next time.